Here's the problem we were just looking at a second ago, and I showed you a method wherein we just did this all in one big equation that contained all of the ijk components in it. The other main way to do this, I wish I hadn't just dropped my eraser as the video started, hang on. The other main way to do this is to separate everything into separate x and y components at the beginning and put them back together later. Mathematically speaking, you're doing the same thing. You notice that when we did all the work that was up here a moment ago, I never mixed any of the I pieces with any of the j pieces. They never multiplied or added or did anything. They were just separate components. Well, I can do that from the outset. In other words, instead of just writing these out in ijk notation, I could instead, when I set up my problem, say, all right, well, I've got an initial velocity component in the x direction, which I might write as Vox, that was it 30? I shouldn't have erased that before I remembered what it was. Yeah, I believe that was 30. Yeah, that sounds good. And then an initial velocity vector in the y direction, an initial y component, which was, I believe, 40. Apologies if that's not actually correct. Now this conveys the same information that the ijk notation did. The ijk notation told me that I had an x component that was 30 by having 30 I hat, and a y component that was 40 by having 40 j hat, or I could write it here as two separate components. Notice I'm not writing the explicit vector signs above them now, because this really just represents not the full vector. We're not writing it in ijk notation. However, you still want to make sure, if we break this down into x and y components, that you're keeping track of what's positive and what's negative. That is, -2 plus 2. I could rewrite my acceleration vector as an x component, ax, that was -2, and a y component for a that was +2. And again, I've conveyed the same information that -2 I hat plus 2 j hat does, namely that I have an x component that's -2, or 2 to the left, and a y component that's +2, or 2 up. And then, what I would do next is I would just break the whole problem down into an x direction part and a y direction part. Because we already saw, both in that last example and just in general working with vectors, that you can really just combine all the x components and then separately combine all the y components, and then if you want the total, you just kind of add them together at the end. And so I could write that same vector equation. Now it's not necessary to put the little x's on every term like I have in here, but I like to do it because it's very useful just as a reminder that I'm only looking at x components. Even if some of these vectors don't have x components, they just won't show up on this side. And likewise, here I put a bunch of y's to indicate I'm working with y components. Well, my x component of the initial velocity vector was 30. The x component of the acceleration vector was -2. And the time is 10. Time didn't have components. It's not a vector. It just shows up over here. Likewise, the y component, my y component of my initial velocity vector was 40. Y component of the acceleration vector is +2. The time is 10. When I do this calculation, I get 30 minus 20, so I get 10 meters per second, +10 for the x component. And over here I get 40 plus 20, or 60 meters per second, positive direction, for the y component. And you'll notice this is the same set of math I did in the previous video. I just did it all in one line. Because the previous video was 30 I hat plus -2 I hat times 10. gave me 10 I hat. And then also at separate points in that equation, I had a 40 j hat plus 2 j hat times 10, which gave me 60 j hat. This has given me the same information, and I can put it back together into one final vector by just taking the x component with an I hat and the y component with a j hat. And those are the two common ways to work a multidimensional kinematics problem, either to do them all in line with the ij's and k's and just group the i's, group the j's, group the k's, or effectively group the i's, j's, and k's before you start by separating them all up and then having separate columns that you can solve. And either way, you have the same amount of information. Here you have effectively two equations, so you could solve for two unknowns if you wanted to, like these two unknowns. But a vector equation is really also two equations if all the vectors are two-dimensional, or it's three equations if all the vectors are three-dimensional, because it contains all the information that is contained in each individual equation.